right, let's dive into this. Teleportation. I mean, come on. It's always been one of those things that just, captures the imagination.
It really does.
And you said some really interesting sources on this. So let's unpack it. Let's separate the science fiction from the actual science that's happening right now.
Yeah, and there's a lot of both. It seems like science fiction is slowly becoming science fact, especially in the quantum world.
So before we get too deep into the quantum stuff, maybe just for people who've never even thought about this before,
Yeah,
what even is teleportation?
that's a great question.
Are we talking like Star Trek beaming up Scotty?
Well, yeah, I mean, the classic idea, right, is instantly transporting matter, like from one point to another without actually physically crossing the space.
Right.
And I think that's still very much in the realm of science fiction. But what is happening is in the quantum world, which is pretty mind-boggling in its own right.
So when we say quantum teleportation, what are we actually teleporting?
We're not teleporting the actual object itself. It's more about the information. That describes its quantum state.
Oh.
So like imagine you're sending a blueprint to perfectly recreate something.
Right.
Rather than sending the actual thing.
Oh, okay. So it's not like we're physically moving something. It's like we're transmitting the information to rebuild it somewhere else instantly.
Exactly.
But how is that even possible? How do you even do that?
So that's where this whole idea of quantum entanglement comes in, which is pretty wild. It's essentially, two particles that are linked in a way that kind of defies our classical understanding of physics. So no matter how far apart they are, if you change the state of one, the other one instantly changes to match it.
So wait, if I mess with a particle here on Earth, its entangled partner, across the galaxy, would know instantly. Isn't that breaking, like, the speed of light?
Yeah, I mean, it is. It's one of the most puzzling aspects of quantum mechanics. Even Einstein called it, spooky action at a distance.
Right.
But that connection is the key to how quantum teleportation works.
Okay, all right. Well, you said you're going to blow my mind, so I'm ready.
Yeah.
Walk me through, how do they actually do this? How do they actually use this spooky action?
Yeah, so it involves three particles. You have two that are entangled. And then you have a third particle that carries the information that you want to teleport, like the quantum state of an atom, for example.
Right.
So what scientists do is they interact that third particle with one of the entangled ones, essentially extracting the information about its state.
Okay.
And then through the magic of entanglement, that information is instantaneously reflected in the other entangled particle, which could be miles away.
Wow.
So you're not sending the atom itself.
Right. You're sending the instructions to rebuild it.
You're sending the instructions to recreate it at a distant location.
That's wild. But I mean, is this just theoretical, or are scientists actually doing this?
Oh, no, it's not just theoretical. Researchers have successfully teleported the quantum states of photons and even atoms across labs and, over increasingly longer distances.
Yeah. So quantum teleportation is really happening right now.
It is.
That's amazing. Are there any really crazy examples of this that have happened?
Yeah, I mean, a few years ago, Chinese scientists teleported information to a satellite orbiting over 1,200 kilometers above Earth.
Whoa.
It's pretty incredible.
So they're actually beaming stuff up into space.
They're beaming information up into space. And this is really just the beginning.
That's amazing. It sounds like we're on the verge of some serious breakthroughs here.
Absolutely.
Where do you see this going? What are the biggest possibilities for this technology?
I think some of the most exciting applications are in quantum computing and communication. So, imagine a future where we can send information instantly and securely without any risk of eavesdropping.
That would be incredible.
Yeah.
That sounds like a world changer right there.
Right.
How would that even work? How would quantum teleportation make communication that secure?
So because of the nature of entanglement, any attempt to intercept the information would disrupt the entangled state.
Oh, yeah. And that would alert both the sender and receiver. So it's like a built-in alarm system for your messages.
Oh, so it's unhackable.
Essentially. Yeah.
That's wild. What about quantum computing? I've heard a lot about that too. How does teleportation tie into that?
So one of the big challenges with building powerful quantum computers is connecting distant quantum processors.
Okay.
And quantum teleportation could be the key to creating these super powerful computing networks.
So we could have quantum computers all over the world.
Yeah.
Working together. All linked up through teleportation. I mean, this is straight out of a movie.
It does sound that way, doesn't it?
But it's actually happening.
It's real, yeah.
It's pretty wild. And speaking of movies,
the
question that always comes up, could we ever teleport people? Like, is that something that beaming me up, Scotty? Is that ever going to be a reality? I mean, that's the big question, isn't it? And I think, with our current understanding and technology, teleporting a person is still very much science fiction. There are just some massive hurdles to overcome.
Okay.
Both technical and philosophical.
Like what are the biggest challenges?
Well, I mean, just imagine the sheer amount of information needed to describe a human being. Every atom, every molecule, every, tiny little detail. Encoding and transmitting that much data is just astronomically beyond what we're capable of right now.
Yeah, I mean, that makes sense. It's an unbelievable amount of data.
Yeah.
But even if we could somehow do that, wouldn't maintaining entanglement over that kind of distance be basically impossible?
Yeah, that's another huge hurdle. Entanglement is incredibly fragile.
Right.
And maintaining that connection over the distances needed to teleport a person, I mean, it would be so difficult. The particles could easily become decoherent, meaning they lose that link.
So even if we had all the information and we encoded it somehow,
yeah, right,
getting it to stay entangled over that distance is a whole other.
It's a whole other challenge, yeah. And then you get into these kind of mind-boggling philosophical questions.
Yeah.
If we could teleport a person, what happens to the original?
Right.
Is the teleported version an exact copy? Or is it something else entirely?
Yeah, I mean, that's getting into some deep
stuff.
Territory there. We're talking about identity and consciousness and what makes you.
Exactly. It's kind of like that old thought experiment, if you gradually replace every part of a ship, is it still the same ship? But now we're talking about replacing every atom of a person. It really makes you question what defines us.
Wow. It's like teleportation makes us rethink what's even real.
It does.
If you can send information instantly, does that change how we think about distance?
Yeah.
Does it change how we think about time?
I think it really challenges our sort of conventional way of thinking. And while human teleportation might still be, a long way off, I think the progress that we have made with quantum teleportation is really revolutionizing how we understand the universe.
Yeah.
And opening up these incredible new possibilities.
It's pretty amazing to think that something that was purely science fiction is now something that we're exploring in labs and leading to real breakthroughs.
Absolutely. And it's important to remember that we're really just at the beginning of this journey. Who knows what other mind-blowing discoveries are waiting for us as we kind of delve deeper into these mysteries of quantum mechanics.
Yeah, this whole deep dive into teleportation has given me a whole new perspective on what's possible, and how much we still don't know.
Definitely.
I feel like we could talk about this for hours.
Yeah, there's so much to explore.
Teleportation it's just one of those things that it really makes you think.
It really does. And as we wrap up this deep dive, I think it's worth emphasizing that while we've been focused on teleportation, it's really just one piece of this much bigger revolution that's happening in quantum mechanics.
Yeah, it really feels like we're at the beginning of something huge here. What other kind of advancements are on the horizon in this whole quantum world that you're excited about?
Well, I mean, one area that's super promising is the development of quantum computers.
Yeah, I've heard a little bit about those, but I don't really understand how they work.
Well, they have the potential to completely transform fields like medicine, materials science, artificial intelligence.
Oh, wow.
I mean, we're talking about solving problems that are just impossible for even the most powerful classical computers that we have today.
It's hard to even imagine what that would look like.
It is. It's pretty mind-boggling. Imagine being able to design personalized medicine tailored to an individual's genetic makeup, or developing new materials with properties that we can only dream of right now.
Wow.
Quantum computers could even help us understand the complexities of the human brain in ways that we never thought possible.
It sounds like this quantum revolution has the potential to change the world as we know it.
It really does. But of course, with such powerful technology come big ethical considerations.
Right.
How do we ensure that these advancements are used responsibly? That's a question that scientists, ethicists, policymakers all need to work together to address. We need to establish clear guidelines for the development and use of these technologies, ensuring transparency, accountability, and a focus on the greater good.
Yeah. It's a good reminder that scientific progress should always always go hand in hand
Yeah.
with ethics and sense of responsibility.
Absolutely. As we unlock these secrets of the quantum world, we need to proceed with both caution and a sense of wonder, always keeping in mind the potential impact on humanity and the planet.
Well, I think it's safe to say that this deep dive into teleportation has left us with more questions than answers. But, that's kind of the beauty of science, right?
It is.
It's about embracing the unknown and pushing the boundaries of what we understand.
Absolutely. And as we continue to explore the mysteries of the universe, we can be sure that there are even more mind-blowing discoveries waiting for us just around the corner.
Well, to our listener, thank you for joining us on this incredible journey into the world of teleportation and quantum mechanics.
Yes, thank you.
We hope you've gained a new appreciation for the wonders of science and the endless possibilities that lie ahead.
And until next time, keep exploring, keep questioning, and keep diving deep.